Hello everyone, welcome to our channel Helm of Science. I hope all of you are safe and healthy in this current situation. In the previous video we have discussed about the straight line graph. Today we shall proceed with the exponential one, the parabolic graph, and the last one, that is the hyperbolic graph, right? So let's get started. First we will discuss about the exponential graph. Now in exponential graph we know there are two types of exponential equations. One is, the first one is y equals e to the power x, right? First we will be discussing about this equation only. Now before proceeding on to the graph, at first we have to see the three values of exponential one. That means e to the power 0. What is the value of e to the power 0? You'll have to remember this. The value of e to the power 0 is 1, right? Now what will be the value of e to the power infinity? E to the power infinity, the value will be infinite. And the third one is e to the power minus infinity. What's the value of e to the power minus infinity? It will be 0. So we have to know these three values before we start doing our graph, right? Now if I consider two values, not two values, the x and y values of an equation, I am just plotting the graph. This is y axis, this is x axis, and this is minus x axis, right? So this is the x and y coordinates, right? Now if I put the value of x as minus infinity, what will be the value of y? The value of y will become y equals e to the power minus infinite according to this equation, and its value will become 0. So the value of y will be 0. Now if I put x equals to 0, what will be the value of y? The value of y will be e to the power 0, and its value is 1. And finally if I put the value of x as infinity, the value of y will be e to the power infinite, and its value is also infinite. So students, you can see that with the increase in value of x, the y value is always increasing one. That means here x is proportional to y. So what will be the nature of the graph? The nature of the graph will be an increasing one. That means increasing graph. Okay. So we will get an increasing graph in this y equals e to the power x equation. Now how will be the graph? See, for x equals infinite. Now in a 2D surface or in any surface, it is impossible to locate the exact position of minus infinity. Infinity itself is an infinite term. That means you cannot reach that term, right? So in an axis you cannot define the minus infinity point exactly. So we are considering it as an arbitrary point here and mark it as dotted line, right? That means at x equals to minus infinity, the y value is almost approaching 0, right? Here the coordinate of y is 0. So it is as if it is almost reaching the minus infinity value of x and the 0 value of y, right? Now you can see at x equals 0, there is a value of y. What is it? It is 1. So we are considering y equals to 1 at this point. So we can easily join the line through this point, and it will go on increasing as x equals infinite. That means at infinite value of x, the value of y will be also infinite, right? So here it is an increasing graph. increasing graph. Okay, and this point, this dotted point, it is referred that this line is asymptotic towards which direction? Towards negative x-axis. So this part is asymptotic with respect to the negative x-axis. So in this equation we have found that the graph is increasing one, right? Now we will move on to the next type of equation. It is almost same, just there will be a slight change in the equation. Here it will be e to the power minus x. This is number 2 equation. E to the power minus x, and this value will remain same. Now again we will consider a plot, right? This will be x, this will be y, this will be minus x, right? Again we have to consider the values of x and y in order to find the nature of this graph. Okay, now again we are putting the values of x as minus infinity. Now this time what will be the value of y? It will be, the original equation is e to the power minus x. Now if I put the value of x as minus infinity, how much will it be? It will be e to the power minus of minus infinite. So it will become e to the power infinity, and its value is infinite. So the value of y will become infinite, right? And if I put the value of x as 0, how much will the value of y? It will be e to the power minus 0. That means e to the power 0, and its value is 1. So again the value of y is 1 here. And at x equals to infinity, what will be the value of y? The value of y will be y equals e to the power minus infinity, and its value is equal to 0. So here the value of y will be equal to 0. Okay, I am just moving this. Now see, with the increase in the value of x from minus infinity to plus infinity, the value of y is gradually decreasing from infinite to 1 to 0. That means x here is inversely proportional to y. That means once the value of x will increase, the value of y will go on decreasing gradually. So what will be the nature of the graph? The nature of the graph will be a decreasing one, decreasing graph, right? So now we will move forward to how will the graph will look like. See, at x equals infinity, the value of y is 0. So again you cannot point the exact value of infinity here. So we are just considering this point as x equals infinity, and x equals infinity, y is approaching towards 0 value. So we are mentioning this with a dotted line, right? Now you can see that at x equals 0, the value of y is 1. Again we have considered this value, suppose, as the value of y, which is 1. Okay, now we will again join this line, and it will move forward towards the infinite direction. You can see this is the negative x-axis. That means the negative minus infinity value of x, and at minus infinite value the coordinate y will also have infinity value. That means it will go on increasing up to infinity. Now this will be a decreasing type of graph, right? This will be a decreasing graph, and this dotted value is asymptotic towards which direction of x-axis? This is the positive one, so this will be asymptotic towards positive x-axis. So this is actually a decreasing type of a graph, and this infinite value, that means this point, is actually asymptotic towards the positive x direction. So this was all about the exponential graph. Next we shall move on to the next type of graph, that is the parabolic graph, right? Next we shall move on to parabolic graph. Parabolic graph. So in parabola, the general equation of parabola is y square equal to 4ax. Now we are not bothered with the 4a term. We shall simply discuss with the two terms, that is y square equal to x, right? Y square equals x. Now if I consider different values of y and x respectively, what we will see that if I put the value of y as 0, what will be the value of x? The value of x will also be 0. Okay. Now if I put the value of y as 1, I will find x as 1 also. That means x equals y square, that means 1 square, which is 1. Now if I put y as 2, what will be the value of x? X will be equal to y square, that means 2 squared, that is equal to 4. So x will come out as 4. Similarly for y equal to 3, x will be 9, y equal to 4, x will be 16, and so on, right? So how to plot this in a graph? See, this is positive x axis, this is y axis, this is minus x, and this is minus y axis, right? Now at x equals to 0, y is also 0. So this point is the origin, that is O point. So the first coordinate of this graph is this one. Now at x equals 1, suppose I am pointing at 1, 2, 3, 4, 5, 6, and so on. 7, 8, 9, and so on, right? I'm not going any further. Now I'll also plot this as 1, 2, 3, 4, and so on. Now see, at x equals 1, the value of y is also 1. So at x equals 1, the value of y will come here. That is, this point is x equal to 1 and y equal to 1. Now at y equals 2, the value of x will be how much? 4. So at y equals 2, the value of x is 4. That means here. Okay. And at y equals 3, that means here, the value of x will be 9. That means somewhere in this region. So you can see, and it will move further like this, right? So this is the actual parabolic graph. So the line will move on and on along with the increase in the values of x and y. Now I am also making the negative values. I am also considering the negative values. That means if I consider y as minus 1, what will be the value of x? X will also be minus 1 squared. That means 1. That means 1. Value of x will be 1. And for minus 2, for y equal to minus 2, x will be minus 2 squared. That means it will be 4 followed by minus 3, and it will be 9, minus 4, it will be 16. So you can see, for the negative y axis, the x values are also remaining same. So how to plot this one? We will point this as minus 1, minus 2, minus 3, minus 3 and minus 4, right? So at y equals minus 1, the value of x is again 1 here. Here it is 1. Y equals minus 2, the value of x is 4. So it will lie somewhere here. For minus 3, that means here the coordinate will lie at 9. So it will go on like this. So in this way a parabolic graph is actually looks like. This is what a parabolic graph looks like. Now I am giving you a small trick as to how to find or how will be the plot by just seeing the equation, seeing the parabolic equation. Suppose you are given y square equals minus x, right? So the graph will lie on the negative x axis. The plot will be on the negative x direction. You will always remember that this parabolic curve will be tilted towards that coordinate which has the power 1, right? So here you can write a small trick. You can consider is a trick that tells that the curve will lie to that part of the graph. The curve will lie to that part of the graph whose coordinate has the power 1. Right, here you can see the power of x is 1, right? So that's why the curve is towards the negative x direction. This is the negative portion, this is the positive portion of x. Similarly, if I say x square equals to y for this equation, where will be the how will be the curve look like? It will look like, see here the coefficient or the power of y is 1, so the curve will be along the positive y direction. It will be like this, that is in the positive y direction. And for this equation I have already solved. The nature of the curve will be like this, that means in the positive x direction, as the x value has the power 1. And similarly another one will be there for x equals to minus y. For this particular equation the curve will be somewhat like this. This will be on the negative part of y axis. That means this is negative y, this is x, this is y, and this is minus x. So this is a small trick as to how to find out the nature of the curve in case of a parabolic graph, right? So this was all about the parabolic one. Now we shall move on to the next and the last type of graph, that is the hyperbolic one. Now we shall move on to the hyperbolic graph. Hyperbolic graph. Here the general form of hyperbola, that means the form of a rectangular hyperbola is like x to the power a, y to the power b equals to some constant value. Constant. This is the equation for hyperbole, that means rectangular hyperbola to be specific. Now here you have to remember that a and b must have positive values. Positive values. That means a and b, the power of x and y must be positive. It can't be negative, right? Now in first case, if I consider a equals to 1 and b equals to 1, we will have equation xy equals to constant. Now for xy equal to constant, from y equals to what we'll get constant by x. So we can say that y is inversely proportional to x, right? From this equation we can get y is inversely proportional to x, right? So what will be the nature of the graph? If this is x, this is y, the value of the graph will be somewhat like this, right? It is decreasing. It is a decreasing sort of a graph. Now if I consider a equals 2 and b equals 1, so we will get x square y equals to constant and y will become constant by x square. In this case x and this is y. What will be the what will be the nature of this curve? This curve will be almost same, but it will have a more steeper value. That means it will be more steeper, right? In this aspect, so you can ask me that what is the reason behind the steepness of this curve? Here you have to remember that with the increase in the power, the steepness will be also increased. So you can write here that more the steepness, more the power, more will be the steepness. That means with the increase in this power, the steepness of the graph will be increased, right? Now if I put a equals 3, if I put a equals 3 and b equals 1, we will get x cubed y equals to constant. From here we will get y equals to constant by x cubed. So in this case the plot will be further more steep. That means it will be like this. So you can see with the increasing power the steepness will also increase, right? So these are the three processes. Now if I summarize these three equations, if I write for a equal to b equal to 1, what we have found, we will get this type of a graph, and for a equal to 2, b equal to 1, what we have got? We have got a more steeper value, that means more steeper slope, the steeper graph, and for a equals to 3, b equal to 1, we have got much more steeper curve. So these are the three types of graphs, right? And if I ask you that whose slope will be highest, so if I point it as b, this is c and this is a, you'll always know that more the steepness of the curve, more will be the slope. So slope order will be c greater than b greater than a. Why c is the highest? Because its steepness is the highest among a, b and c. So this was all about the concept of graph. I hope everyone enjoyed the video. If you do, then share it among your friends and your family members, and do subscribe to our channel and hit the bell icon. So in the next video we shall start with a whole new chapter of chemistry. Until then, all of you try to stay at home and stay safe. Thank you so much.